Happy St. Patrick's Day, everybody. I'm trying to do this a little quickly because YouTube keeps on crashing on me. Anyway, this is a simple series circuit that we're going to analyze together, just as an example. There's a 6-volt battery, a 10, 20, and 30 ohm resistors, and they're all in series, right? There's only one place for the current to go through. And so if I wanted to know the total resistance of this circuit, I could just apply the rule that was talked about in the Edpuzzle video. I would just add up the three resistances. And so I would have a total resistance of 60 ohms. In other words, this 6-volt battery has to push charges through each of these resistors. And so I'm just going to have to add up the resistances of each of those resistors. And so I could redraw this circuit. This battery, if I connected it to a 60 ohm resistor only, it would push out the same amount of current as in this circuit. And so if I wanted to calculate how much current that was, I would just apply Ohm's law. Right? Ohm's law would say that current is voltage divided by resistance. And so I've got a 6-volt battery, 60 ohms of total resistance in either one of these circuits, and that would give me 0.1 amps. Now, since 0.1 amps is being pushed through the battery and there's no place for the current to split off, that 0.1 amps has to go through R3, R2, and R1. And so that's what's unique about a series circuit. Everything that's in series will get the same amount of current through it. Now, of course, as the current is traveling through these resistors are giving off heat, so the energy of the charges that the battery gave to the charges is now being converted into heat. And so there's going to be a loss in energy as you go through each one of these resistors, and that will be what the voltage is, right? The voltage is energy per charge. And to calculate how much voltage is lost as the current travels through each of these resistors, I'm again going to use Ohm's law, but I'm going to rearrange it. That voltage drop will be the current times the resistance. So I'll multiply the current I times the resistance R, and here I'll have 1 volt across 1 volt drop across R1, a 2 volt drop across R2, and a 3 volt drop across R3. Again, all I'm doing is taking current times resistance. And there's a way to check that, right? Kirchhoff's loop rule would say that if you travel in one closed loop, the voltage gains, here would be a gain of 6 volts through the battery, would be equal to the voltage losses. So I have 1 plus 2 plus 3. I've got a total of 6 volts lost through these through these 3 resistors, and 6 volts gained through the battery. So that does check out. Okay, again, the loop rule. For any closed loop, the sum of the voltage drops and the voltage losses will have to be 0. Plus 6 minus 3 minus 2 minus 1 gets you back to 0. So it does check out. When we go and analyze a parallel circuit, like this simple parallel circuit, take the same 3 resistors, and this time we put it in parallel instead of series. So different analysis has to be done here, because to find the equivalent resistance for a parallel circuit, you'll add up the reciprocals of all of those. So it would be 1 over R1 plus 1 over R2 plus 1 over R3, etc., etc. So let's try this one. So I'll take 1 over R, I'm going to call it the equivalent resistance. That'll be 1 over 10 plus 1 over 20 plus 1 over 30. Okay, that does not give you 1 over 60, right? We have to come up with a common denominator, which will be 60. So let's make this one 6/60ths, make this one 3/60ths, and make this one 2/60ths, right? We're just multiplying top and bottom by the same factor to get our result. And so what do we end up with? 9. We have 11 over 60. That is not the equivalent resistance. That is the reciprocal of the equivalent resistance. So to find the equivalent resistance, I will then take the reciprocal, and so that will be 60 over 11. And, which is, what is that, about 5.5 ohms. And So I'll put that in here. You know what, I'm going to leave it at 60 over 11, just because I think it'll make my calculations easier later. Excuse me. So in other words, what I could do is I could take this same battery, and if I hook that same battery up to one single resistor that had a resistance of 60 over 11 ohms, it would produce the same amount of current through the battery. Right? Because the reason why this resistance is so much smaller than before is now there are multiple paths for the current to take. So the current that pumps out through the battery is going to split among these three resistors. And since there's more places for the current to go, that's less total resistance. Okay? So let's figure out how much current is going through the battery by looking at this equivalent resistance and this battery voltage of 6 volts. And again, all we have to do is use Ohm's law. Ohm's law states that the current equals the voltage divided by the resistance. And here, of course, I'm going to use the equivalent resistance. So that is 6 volts, and I'm going to divide it by 60 over 11. So that's dividing by 60 and multiplying by 11. Right? When I divide by a fraction, I multiply by the reciprocal. And so that would give me 66 over 60, which would be like 1.1. Well, that's kind of nice. That's at least a more decent number to work with. Okay, but what's different about this and the series circuit is each of these resistors do not get 1.1 amps. There's a total of 1.1 amps flowing